Yesterday's lecture also I have posted the audio, huh? Complete explanation audio video is posted in the Google Classroom. Now, yesterday we did a diagram of two component system where I just told you about the different labeling that is being done in the phase diagram for two component system. Okay. Now, generally, this two component system means you understand there are two constituents, two minimum number of constituents that is required to describe the entire phase diagram. Correct. Now, it so happens that for a two component system, generally, if the phases are four, okay, if the phases are four, the degree of freedom, if you calculate and if you see, it comes to zero. You can see in the slide first point itself, where if the degree of freedom is zero, number of phases is equal to four, or if the number of phases is four, the degree of freedom is zero. ठीक है. अब फोर फेजेस एक फेज डायग्राम में एग्जिस्ट करना और उसको शो करना, that is really a quite a difficult task, because you know what happens, four different phases means generally there are solid, or there may be two solid, one liquid and one gaseous phase. ठीक है. Similarly, we can also think in this way, for a two component system, the degree of freedom, if it is 3, maximum degree of freedom should be 3. Then 3 हमें कैसे मिलेगा? That time the number of phase is equal to 1. Okay. So for a two components, these are just the possibilities which I am discussing with you. Then I will discuss with you the actual one. Okay. So if the degree of freedom is 3, the number of component is 2, then the number of phases comes to around 1. Okay. One phase entirely, say a solid phase, or say a liquid phase, or say a gaseous phase, difficult to explain the entire phase diagram. Again, it is little bit controversial कि अगर डिग्री ऑफ फ्रीडम 3 भी रहेगा तो वन फेज रहेगा, टू कंपोनेंट तो फिक्स है, और अगर डिग्री ऑफ फ्रीडम 0 रहेगा तो फोर फेजेस कैसे शो करेंगे, ये भी एक है. ठीक है. बट डिग्री ऑफ फ्रीडम, इफ यू जस्ट रिकॉल द डेफिनेशन, the degree of freedom speaks about the three important factors. What are the three important factors? Temperature, pressure and concentration. Concentration in terms of composition. ठीक है. तो ये थ्री इंपॉर्टेंट जो वेरिएबल्स है या थ्री इंपॉर्टेंट फैक्टर्स है जो डिग्री ऑफ फ्रीडम को एक्सप्लेन करते हैं, ये मैक्सिमम है. But degree of freedom also says in the definition, take the smallest number. So three important factors are there, then two can be the smallest number. So at the most, the degree of freedom required for a two component system can be 2. Okay. So in that case, if 2 is the degree of freedom, number of component is also 2. What will be the number of phases? Can anyone tell me? Yes, degree of freedom is 2. Number of components is also 2. Number of phases is how much? 2. So there is a possibility. Hello, am I audible?
Yes, ma'am.
Yes, ma'am.
So there is a possible, okay, two phases can be helpful or can be able to describe the entire phase diagram. Okay, but three variables को two component system में directly show करना, जो कि temperature, pressure, concentration है, तीनों को एक phase diagram में show करना, it's like a 3D diagram, but still it can be converted into 2D by keeping one of the variable constant. ठीक है, by keeping one of the variable constant, because you have already seen in one component system where a phase diagram was plotted in terms of pressure against temperature, where composition was not at all of so much importance, because water system था जहाँ पे अपने को सॉलिड आइस दिखाना था, वाटर दिखाना था, वाटर वेपर दिखाना था, तो उसके लिए कॉम्पोजिशन की जरूरत नहीं थी. तो वो चीज जो थी वो कांस्टेंट थी या फिर वो प्रेजेंट भी थी, तो दैट वाज इग्नोर्ड. तो प्रेशर अगेंस्ट टेम्परेचर वर द मेजर इंपॉर्टेंट वेरिएबल्स टू डिस्क्राइब द एंटायर फेज डायग्राम. ठीक है. अब हर वक्त हम लोग ऐसा वाटर सिस्टम नहीं करेंगे, हम कोई दूसरा सिस्टम भी कर सकते हैं, जैसे कि एलॉय फॉर्मेशन। अब एलॉयज को जब फॉर्म करते हैं, एलॉयज का डेफिनेशन बोलता है इट इज अ होमोजीनियस मिक्सचर of two or more metals or a metal and a non-metal. अब एक मेटल को लो और दूसरे मेटल को लो, उसको मिक्सअप करो, उसको होमोजीनियस बनाओ, है ना, and make it into one single compound, which we call it as alloy. So the major task or the major variable which comes into the picture is the composition or concentration, and second is the temperature at which these things happen. समझ में आ रहा है मैंने क्या बोला? जैसे कि हम एलॉय फॉर्मेशन करते हैं, एलॉय क्या कहता है? आई एम अ होमोजीनियस मिक्सचर ऑफ टू और मोर मेटल्स और वन मेटल एंड अ नॉन मेटल। ठीक है, अब ये होमोजीनियस मिक्सचर है। जब आप एलॉय को देखते हो, फॉर एग्जांपल आप अपने सीलिंग फैन को ही देखो, सीलिंग फैन किसका बना हुआ है? आयरन का, बट उसके अंदर कार्बन भी मिक्स है। ठीक है, ओके। So, or iron is very soft by nature, so some amount of, say this chromium is also added to make it hard. Sometimes they add copper also to make it hard and stiff. So all these extra metals are added to it. But just by looking at your ceiling fan, can you be able to tell, okay, there is copper, there is carbon, there is iron? No, of course not, because it is a homogeneous mixture. ठीक है, तो here also when we speak about alloy making में what is important is the composition of metals that we use and the composition of alloy which is formed. ठीक है, second thing is the temperature. When we are using two metals, उसका melting temperature क्या है? एक metal और दूसरे metal का, फिर दोनों कौन से temperature पे आके they form a homogeneous mixture. So here the temperature and the composition plays a vital role. So then in such circumstances, we can say even if vapor forms are there, even if vapor forms are there, vapor is present, then that vapors are almost negligible. That means pressure का रोल वहां पे कम है। प्रेशर कहाँ अप्लाई करना पड़ता है? एलॉय सिस्टम में बहुत कम, इनफैक्ट नहीं के बराबर। So when such situation happens where pressure is kept constant with respect to temperature and composition, then the phase rule, the Gibbs phase rule, gets reduced by one variable. Okay, I repeat once again. Position and temperature plays a vital role. These are the two variables which are explaining the entire phase diagram. Then where the pressure is kept constant because it is almost negligible, in fact not present. In such situation, the Gibbs phase rule gets reduced by one variable because the gaseous phase is absent. So when the Gibbs phase rule is reduced by one variable, then the new phase rule which is formed is condensed. Okay, and that condensed phase rule is called as reduced phase rule, which is given as F is equal to C minus P plus 1. Okay, F is equal to C minus P plus 1. For example, you can see over here, this is the lead silver alloy. Okay, lead silver alloy जो है बनाया जा रहा है। ठीक है, अब जब lead silver alloy बनाते हैं तो उसके अंदर solid lead भी लगेगा to react with solid silver, correct or not? So when they will react, they will form a solution of lead silver. ठीक है, so उनको पहले melt करना होगा, melt करने के बाद में cool करना होगा, cool करने के बाद में it will take that desired shape. Correct. So here the temperature is there, how much amount of lead has been used, how much amount of silver has been used, and how much composition of lead and silver has been formed in the end. Okay. all that matters which is related to the composition and temperature. Vapors, can lead be melted to that extent where it will give us lead vapors? No, it is not required, because we are using just the molten lead and molten silver to make it react to combine to give alloy. तो वेपर फेज में वो जाता ही नहीं है, लेट सिल्वर सिस्टम or any other alloy, for example. It doesn't go at all to the vapor phase. ठीक है? So over here, what are the four phases still existing? थोड़ा बहुत vapor form भी हुआ, तो what are the four different phases? There is solid lead, there is solid silver, and there is solution of lead, silver, and the last phase, which is very, very negligible, is the vapor phase. So these are the four phases existing in lead silver system, out of which the vapor phase is very, very negligible. Pressure plays absolutely no role in this. That's the reason the Gibbs phase rule gets reduced by one variable, and then it is written as F is equal to C minus P plus 1. Okay, this phase rule is called as condensed phase rule. Okay, so the two component system. Okay, now over here, if you see, there is two components. Okay, one is solid lead, one is solid silver, the third one is solution of lead and silver, which is formed, which are existing in equilibrium. But we are supposed to take the minimum number. So the minimum number is two component, that is solid lead and solid silver. Okay. So for two component system, there is the best way to explain the two component system. For example, alloy system, the best way is F is equal to C minus P plus 1 by keeping atmospheric pressure as constant, and temperature and composition का phase diagram बनेगा. So condensed phase rule is given as F is equal to C minus P plus 1. Followed everyone? So for two component system, there is reduced or condensed phase rule. For one component system, there is proper Gibbs phase rule, which is F is equal to C minus P plus 2. Okay? Just write down this. I hope you all have followed. Okay. So as discussed in the previous slide, vapor phase is almost negligible. That is, the gaseous pressure is almost nil in this particular situation, such as alloy making situation for two component system. So the major talk is all about temperature versus composition. ठीक है? अब सबसे पहले ये डायग्राम में क्या क्या है उसको स्टडी कर लेते हैं. हाँ, ठीक है? Now on the y-axis, there is this temperature exceeding, and on the x-axis, there is percentage composition, fine, which is exceeding. Now, there is one curve AO, okay? Then there is this curve BO, fine. This curve AO and curve BO, they are meeting at point O, fine. Then there is this area AOB, this area, ठीक है? अब ये एरिया को हमें स्टडी करना है और देखना है कि हाउ डज द एलॉय फॉर्मेशन विच इज लेड सिल्वर एलॉय, ये कैसे फॉर्म होता है, एंड व्हाट इज द बिहेवियर इन इक्विलिब्रियम. We are studying the phase diagram in equilibrium state. We are not studying about the final product which is formed. तो जब लेड और सिल्वर को कंबाइन करके लेड सिल्वर एलॉय बनाया जाता है, तो इक्विलिब्रियम स्टेट में उसकी कंडीशंस क्या रहती है, उसका टेम्परेचर क्या रहता है, उसका कॉम्पोजिशन क्या रहता है, कितने परसेंटेज में रहता है, उसको क्या बोलते हैं, वो सब हम ये फेज डायग्राम में डिस्कस करेंगे. तो सबसे पहले लेट अस जस्ट फोकस ऑन कर्व AO. कर्व AO सबको दिख रहा है? This curve AO, you know, it is the freezing curve of silver AG. Okay. Now, just look at the temperature axis. A is beginning from the temperature 961 degree Celsius. ठीक है, A is beginning from the temperature and it is terminating at the point O where the temperature is 303 degree Celsius. Followed? कहाँ से शुरू हो रहा है? A 961 से शुरू हो रहा है और कहाँ पे वो रुक गया? कब? आके O पे, जहाँ पे टेम्परेचर इज 303 डिग्री Celsius. What is this 961? Why has A started from 961? The reason is that silver का melting point is 961 degree Celsius. ओके, वो मोल्टन स्टेट में हम सिल्वर को लेंगे और उसके साथ में लेड को मिक्स अप करेंगे. ठीक है, समझ में आया? तो ये जो सिल्वर हम यूज कर रहे हैं वो मोल्टन स्टेट में, मोल्टन स्टेट में हम उसको यूज कर रहे हैं और उसके अंदर वी आर गोइंग टू ऐड लेड. सो द प्रोसीजर बिगिंस फ्रॉम दिस पॉइंट ए at 961 डिग्री सेल्सियस वी हैव टेकन सिल्वर. ठीक है, सिल्वर जो है मोल्टन स्टेट में वो रिएक्टेंट है, लेकिन हमको पढ़ना क्या है? इक्विलिब्रियम स्टेट. सो नाउ टू दिस सिल्वर व्हेन lead was added, to this molten silver when lead was added, it was found that slowly and steadily silver was freezing. It was taking the shape, solid shape. Okay, so what happened, as the temperature was coming down, means as and when we were adding smaller and smaller quantities of lead, what happened was lead was going into the silver solution. Lead was mixing into the silver. ठीक है, thereby the temperature was dropping down because silver was freezing. ठीक है, so this was continued and continued. Lead was kept on adding, silver was taking into the lead. वो lead को ले रहा था, lead के साथ में एक homogeneous mixture बना रहा था. ठीक है, so a situation came. Okay, slowly and steadily the temperature kept on dropping and dropping and dropping, where there was solid silver formed along with the saturated solution of lead silver in equilibrium. ठीक है, in equilibrium there was not 100% mixing done. lead and silver का 100% mixing नहीं हुआ था. वहां पे सॉलिड सिल्वर भी वो फॉर्म हो रहा था, एट द सेम टाइम सिल्वर और लेड सोल्यूशन भी फॉर्म हो रहा था. ठीक है, जैसे कि हम आइस और वाटर को लेते हैं, वाटर को जब हम फ्रीज करते हैं तो वो इमीडिएटली आइस नहीं बनाता है, वहां पे लिक्विड वाटर भी रहता है और सॉलिड आइस भी रहता है. वैसा ही कंडीशन इधर भी है. यहाँ पे वो सॉलिड सिल्वर भी है एंड देयर इज द लिक्विड और सैचुरेटेड सॉल्यूशन ऑफ lead and silver. So that continuous procedure of adding lead to the silver was going on. But more and more lead, it was not mixing into silver. Okay, where at what temperature this happened? This happened at point O, where the temperature is 303 degree Celsius. Followed everyone? Okay, so at 303 degrees Celsius, there was this mixture of solid silver and saturated solution of lead and silver. Okay, so all this happened along the curve AO, which began at 961 and terminated at 303 degrees Celsius. So no matter you add more and more lead, it will not mix up. वो excess हो गया. It will separate out. That lead will separate out. It will not mix up. Followed everyone till here? AO curve समझ में आया सबको? Yes or no? कुछ बोलो, क्योंकि डायरेक्टली आप फेज डायग्राम लोगे और पढ़ोगे तो नहीं समझ में आएगा, इसका एक्सप्लेनेशन बहुत इंपॉर्टेंट है.
Yes, ma'am.
Followed everyone? Yeah. Now this happened along the curve AO. Now let us have a look along the curve BO. ठीक है, B is beginning at a temperature of 327 degrees Celsius and terminating or ending at point O. ठीक है, now let us study this. ये जो 327 डिग्री सेल्सियस है at point B, it is the melting point of lead. It is the melting point of lead where molten lead is taken. To this molten lead, quantities of silver are added. ठीक है, जैसे हमने AO में सिल्वर के अंदर लेड को डाला था, वैसे कर्व BO में हम लेड के अंदर को सिल्वर डाल रहे हैं. ठीक है, लेड के अंदर सिल्वर डाल रहे हैं. तो ये जो लिक्विड लेड था, slowly and steadily, when the silver was added, it started freezing. Okay, so the temperature started dropping. ठीक है, and slowly and steady, when as and when we were adding silver continuously to the lead, the temperature kept on dropping, where there was formation of solid lead and there was the saturated solution of lead and silver. So we still kept on adding the silver to this lead until a situation came where no more silver was going into the solution. ठीक है, no more silver was going into the solution. Where it happened at point O at the temperature of 303 degree Celsius. Okay, so curve BO, curve AO, both of them came and met at point O. Okay, so curve BO क्या था? Freezing curve of lead. Curve AO क्या था? Freezing curve of silver. Where along the freezing curve of silver, there existed solid silver and saturated solution of lead and silver. Similarly, along the freezing curve of lead, there is this solid lead and saturated solution of lead and silver. These are the BO. So just let me show you the number of phases along the curve AO and BO. Okay, so along the curve AO, there is solid silver and solution, saturated solution of lead and silver. So two phases, two components, F is equal to C minus P plus 1. Here we are going to make use of reduced phase rule. So F is equal to how much? 1. Similarly, let us have a look at curve BO. Same situation, solid lead plus saturated solution of lead and silver, where F is equal to C minus P plus 1, where the system is univariant. ठीक है, समझ में आया? So in this phase diagram, as I told you, there is freezing curve of silver, freezing curve of lead, there is this point O, and there is this area AOB. Where I am going? Yeah, behind. Now, this curve AO and this curve BO, they meet at point O. Okay. Now let us have a check on what is the composition of lead silver saturated solution over here. It was found that the composition, the alloy consisted of 97.4% lead and 2.6% silver. This composition is called as eutectic composition because it is happening at point O. So this point O is called as eutectic point. ठीक है, तो अब eutectic point में situation क्या है वो हम पढ़ेंगे. Okay. So this curve AO and BO, as I told you, degree Celsius. where curve AO BO दोनों मिलते, तो वहां पे solid silver भी है point O में, there is solid lead also. At the same time, there is saturated solution of lead and silver. So for the two component system, the number of phases are 3, where the degree of freedom is 0. This degree of freedom 0 is representing the system is zero variant और नॉन वेरिएंट एट पॉइंट O. इसका मतलब क्या है? इसका मतलब ये है कि when F is equal to 0 at point O, the composition of lead silver, which is in equilibrium, okay, that composition is fixed, where silver is 2.6% and lead is 97.4%. You try to mix in more amount of silver and lead to it, it will not go into the mixture, okay, because वहां पे सब कुछ क्या हो गया? Freeze हो गया. So over here at point O, there are 3 phases where the degree of freedom is 0. 0 signifies that the composition formed over here of lead and silver is fixed, where it is 97.4% lead and 2.6% silver. This composition, we call it as eutectic composition, which is happening at point O. ठीक है? So now at point O तो हमें समझ में आएगा, लेकिन नीचे below point O there is this temperature 303 degree Celsius. लेकिन below 303 degree Celsius, what is the situation? That also we should know. So below 303 degree Celsius, obviously there is this eutectic composition plus solid silver, in which crystalline silver and solid eutectic are stable over here. Just have a look at the phase diagram over here. ये जो O के नीचे का पोर्शन है along the curve AO and along the curve BO, ठीक है, ये डॉटेड लाइन से दोनों कर्व्स को हमने यहाँ पे सेपरेट किया है. तो AO के नीचे का जो 303 डिग्री सेल्सियस का जो नीचे का पोर्शन है, वहां पे क्या प्रेजेंट है? देयर इज दिस सॉलिड eutectic mixture, lead and silver, and there is solid silver also existing. Similarly, curve BO के नीचे देखो, below the 303 degree Celsius, there is the solid eutectic mixture plus solid lead. ठीक है? So when we had began this experiment, that time along the curve AO there was 100% silver, no lead was present in the beginning when we had started. Similarly, in the beginning when along the curve BO, when we had started, there was only the lead which was present, which is 100% lead and 0% silver. But when the experiment started and when the temperature started dropping down, both the curves, okay, both the curves, they came and got halted over here at point O, okay, where we have the solid eutectic mixture, that is lead silver solution and lead silver solid metals, okay. This is happening below 303 degrees Celsius. And what is the eutectic composition? It is 97.4% lead and 2.6% silver. ठीक है, समझ में आया इतना? So let us write down these curves AO and curves BO. उसमें आपको क्या लिखना है? खाली ये थर्ड पॉइंट कर्व AO हेडिंग डालो और खाली ये थर्ड पॉइंट लिखो, ठीक है? Okay. Now this area AOB, it represents solution of silver and lead. ठीक है? So if I ये जो overall अगर देखेंगे area, let me take you just like this area AOB, where there is only this liquid lead and liquid silver. Okay, so there is solution of lead and silver. So if I tell you there is only one phase which is existing, so when there is one phase and two components, what can be the degree of freedom? Calculate करके बोलो mind में. One phase which is saturated solution of lead and silver, if that is present, okay, the number of phase is 1 and components are 2. What is the degree of freedom?
2.
Yeah, exactly. 2. So 2 it says that the system is bivariant where we need both temperature and composition to describe the entire system. How do we need two different parameters? Because, for example, if a sample of lead containing less than 2.6% silver is taken somewhere maybe at the curve B, on the curve OB. Okay. So what will happen? What do you think? On allowing the mass to pull, definitely the temperature will drop, but there won't be any change in composition till this point is reached on the curve BO. I'm sure जो मैंने आपको बोला वो नहीं समझा, correct? अब मैं आपको ये डायग्राम में दिखाती हूँ. Over here, this point, ये जो arrow mark दिख रहा है ना, freezing curve of PB, just to have a look on the curve OB, ठीक है? ये कर्व में, ठीक है, अभी मैंने लेड का लिया, फॉर एग्जांपल लेड इज ऑलरेडी प्रेजेंट एंड आई स्टार्ट एडिंग सिल्वर टू इट. Okay, the silver which is added is less than 2.6%. Obviously, when I will add lead to this, when I will add this silver to the lead, what will happen? The temperature will drop, and it will come somewhere around this curve BO. And same situation will occur where at point O, there is only this eutectic composition is present. This indicates that, okay, when falls, the composition remains the same. When the temperature is gradually falling, obviously it will fall. हमने molten lead लिया, उसके अंदर silver डाला, वो silver जो है 2.6% से कम है, तो जो उसका end में composition रहेगा वही उसका फाइनल कंपोजिशन रहेगा. मान लो 2.6% या लेस देन 2.6%, वही उसका फाइनल कंपोजिशन रहेगा अलोंग द कर्व DO. ओके, सो ये एक एडिशनल पॉइंट था AOB को एक्सप्लेन करने का. अदरवाइज इट इज वेरी सिंपल टू अंडरस्टैंड दैट एरिया AOB represent solution of lead and silver where there is number of phases 1, number of components is 2, and F is equal to 2, where the system is bivariant. Okay, so these are the two different curves, OA and OB, and the eutectic point O and area AOB. Okay, so this is the entire explanation of the phase diagram for two component system. Have you all followed it very nicely? सिंपली एक्सप्लेनेशन है, बट टेम्परेचर और कंपोजिशन, जो यूटेक्टिक कंपोजिशन है, वो आपको एकदम प्रॉपरली दिखाना है ग्राफ में. ग्राफ इटसेल्फ इज वेरी मच सेल्फ एक्सप्लेनेटरी. ओके,
Yes, ma'am.
so with this we complete our two component system also. Now let's have a look on the applications, that is advantages and disadvantages. Obviously phase rule is applicable to both physical and chemical equilibrium. Okay, so components may not play that much bigger role in it. Okay, and it is microscopic study. Now one thing is there, all the chemical reactions, they may not attain equilibrium. Okay, so here the phase rule has a little bit diagram, because phase rule explains only the equilibrium state where there is variables temperature, pressure, and composition, and there is no discussion about electrical and magnetic forces. That is the only drawback. Okay, so over here also it takes only into account the number of phases and not their quantities. जैसे कि हमने बहुत सारी चीजें जो है, when while starting with the phase rule, many things must have come to your mind कि अगर हम solid ice है तो वो कितने quantity का है and all. Okay, so with this we complete with our theory part of phase rule. Both one component and two component is important. What is the time? Okay, let me take the
3:11.
attendance. I thought I will start with the numerical. हाँ अभी attendance का हो गया. Attendance दो, then I will give you explanation on assignment. ठीक है? Put it in the chat box. Recording is not stopped.